Hello and welcome to another video in this series about object-oriented programming. In this Under the Hood video about initialization blocks, I'll demonstrate what the effect is in memory when an instance initialization block is executed at the time of object creation. This is the rectangle class as implemented in the hands-on video for version 8. So we were implementing this count mechanism using a private static integer named count, a public getter returning the count, so we encapsulated the count variable. The main difference with version 7 is the presence of this instance initialization block incrementing the count instead of the constructor incrementing it. And as well the presence of this 3 parameters constructor chained to the 4 parameters constructor. And the client code I'll examine under the hood step by step in the next slide is very similar to the client code of the previous version. So what I'll examine is the following. First, we print the count by invoking the static getCount method. Then we create a rectangle using the 4 parameters constructor and print it out. Then we create a rectangle by passing 3 arguments to the 3 parameters constructor and printing it out. And finally we print the count again. And so what I want to focus on is the timing between the execution of the initialization block and the constructor. Let's dive under the hood and discover what happens in memory when we create an instance, because it's going to be a bit different compared to the previous versions. So the first statement is the printing out of the count by invoking the static getCount method as demonstrated in the Under the Hood video of version 7. Since this is the first time that the runtime uses something of the rectangle class, namely invoking a static method, class code of the rectangle will be loaded in memory and allocating the static variables in the static area in the process and initializing them. So we have all the minima and maxima and our count. Now what happens when we create an object? So a slight difference compared to version 7. What is similar is the allocation of the local variable on the stack, the creation of the object on the heap due to the new keyword, but then, and here's the difference, as I explained in the introduction in the hands-on video, before executing the setters of the constructor, the runtime invokes the instance initialization block, thereby incrementing the count in the process. Once that is done, control resumes in the constructor, thereby invoking the setters. So the count is not executed in the constructor anymore. We took it out and moved it to the instance initialization block. That's for the creation of the object. Finally, the assignment of rect1. If we print it out, then we have the same output as before. For the second objects, using the 3 parameters constructor to which we pass 3 arguments. So first allocation of rect2, then the creation of the object on the heap due to new, executing the 3 parameters constructor, which is chained to the 4 parameters constructor. That one is invoked, but not yet executed. First, the automatic invocation of the instance initialization block, incrementing the count from 1 to 2. After which control resumes in the 4 parameters constructor, executing its setters. And that's it for the creation and initialization of the second object. Finally, assigning the address of the second object to rect2. Printing it out as before and printing the count, which is set to 2. So the difference to remember here compared to version 7 is the execution order. First, the initialization block is executed, incrementing the count in the process. After that, the actual constructor executing its setters. That's it for this video. Thank you for watching and see you in the next version, where I will extend the library of shapes by adding the circle class. Bye bye.